Welcome class to Graphing Inequalities, and today we are going to take an inequality which is very similar to a line and show how graphically it looks very different. So we have our learning target is I can show the solution to an inequality graphically, because that's really what graphs are. It's a visual way of showing the solution. A line is a line because only the points on that line are the solution that will make the line equal to each other, the x and y combos that will make it work. But with inequalities, there's an entire chunk of the graph. Anything in there will be a solution. Okay, so I'm going to get rid of this title so we have some room to work. Alright, there we go. I'm going to slide this over. So we want to graph the inequality y is less than x plus 3. Now, just because it's an inequality doesn't mean that we don't have to keep in mind the same form. Remember, the form of a line is y equals mx plus b. But it's not equals, that's all. It's just less than or greater than or equal to, less than or equal to. Same deal, though. We want the mx plus b in the same spot. We want the y in the same spot. So we don't have to do anything. It's m is 1. That's this little one right here is in the m spot. And then b is 3, and that's the b spot right there, the y-intercept. So we're going to still start with a y-intercept of 3. And this time a slope of 1 will be up 1, right 1. So we want it as a fraction sometimes. So it looks like this. And this is where it gets different. So before you take out your ruler and immediately draw this line, we have to decide if the line I'm about to draw includes, if we include that in our solution. So a line, if you're drawing a line, not an inequality, excuse me, if you do an equation, not an inequality, the line is the only thing that's the solution. But this time, sometimes the line is not a part of the solution. And if you notice, we have less than. So y is just less than x plus 3. Well, we just graphed x plus 3, and it's everything less than that. So it is not a part of the line, because it would be exactly that. So to indicate that, you still use your ruler, but instead of going just in a straight line, you do dots. Kind of looks like I have dots already there. But you want to very clearly indicate that it is a dotted line. And again, you still use your ruler. It still should be very straight, but it can't be filled in. Alright, now, so far, technically, there's no solution still here because I've only drawn a dotted line, which means the solution's not on that line. But it is all of the graph below it or all of the graph above it. And that's where I have two tactics. One really easy way, and another way that guarantees you're right or wrong. So this says y. So remember, these are the y values. If you think of these as the y values, we want all the y values that are less than x plus 3. Well, if this is x plus 3, all the y values that are less than it are below the line. So let me get rid of this stuff. I want to shade in all of the values less than this line, and that looks like that. So now what I can do is pick a point in my solution. So I'm going to pick, I always pick something easy. If 0, 0 is in there, I pick it. So I'm going to pick 0, 0, and I'm going to check to see if 0, 0 is a part of the solution. So I have y is less than x plus 3. Remember, this is x, this is y. Plug 0 in for both. 0 is less than 0 plus 3. And 0 is less than 3, so I know that I shaded the correct side. It doesn't tell me that my line was right. It just tells me I shaded the side correctly. Alright, let's try something else. Alright, we have the line x minus 2y is less than or equal to 4. So we're going to have to do some editing here. Because we want it to be solved for y. So that means I got to get rid of the x, move it to this side, I get negative 2y is less than or equal to, I kind of want to keep it in the right form, so I'm going to put the negative x first, and then the plus 4, and then divide by negative 2. Now if you noticed, I'm dividing by a negative 2. So this right here is still affected, just like it was in that first unit. So we say greater than or equal to now, and this becomes a positive 1 over 2, or 1/2 x, and then a minus 2. Okay, so I'm going to graph this. This is a y-intercept of negative 2. I kind of switched the order here, and a slope of 1/2. So that means I'm starting here at negative 2, and I'm going up 1, right 2. Alright, so this time when I'm thinking about whether it's a solid line or a dotted line, I look up at the original. It doesn't matter, that didn't change. The inequality sign is an or equals to. So I am including the line here. So that's just a solid line. And now I have to do some figuring out if it's shaded or not. So I look at my final equation and it says y is greater than 1/2 x minus 2. That means I want to shade above the line. So I'm going to go in and put my shading here. If you have a pencil, you can actually, for real shade, do kind of a light solid color. But if you want to just do that, you can do that too. Alright, now I want to check. So again, 0, 0 is in my solution. So let's check that again. So I'm going to take my blue, 0, 0. I'm going to check it. Kind of ran out of room here. I'm going to erase some stuff. That's okay, because I want to check it with my original solution anyway, or my original inequality. X minus 2y is less than or equal to 4. So I'm going to put a 0 in here. Minus 2 times 0 here is less than or equal to 4. This ends up just being 0 is less than or equal to 4, which is true. So we shaded the correct side. Alright, we're going to do one more in this video. This time the equation looks crazy, but it's really not that bad. So it starts off with 1/2 y is less than 1/4 x minus 1. So again, we want to get rid of the fractions, but we're not going to do it quite the same way we did before, because our ultimate goal is to just solve for y. It's not so much to find a value for x or a value for y. So normally I would take the LCD, which is 4, and multiply everything by 4, but that'll still leave me with something stuck to the y. It'll leave me 2y. And I don't really care if I get a fraction still. So I'm not doing the LCD way this time. I just want to get rid of the 2 on the bottom over here. But I still have to multiply everything by 2. That'll get rid of the 1/2 and leave me with y is less than. Now here I'm still going to wind up with a fraction, and that's okay. When I reduce, or simplify 2 over 4, that leaves me with a 2 at the bottom. So it's 1/2 x minus 2. Alright, we're going to start at negative 2, because my b is 2 and my m is 1/2. This one seems really familiar here. I think it's is it the same line? It's the same line. Craziness. Okay. But this time I want a dotted line because I have just a less than. And I want to shade, let's see, y is less than. So I'm looking at this, thinking to myself, that must be below the line. So I want to shade below the line. Now here's an interesting tactic. 0, 0 is not in my solution, but it doesn't mean I still can't check with it. If you think about it, the last few times 0, 0 has been in my solution, so I wanted it to work. This time 0, 0 is not in the solution, so I don't want it to work. So I'm going to write my original one. 1/2 y is less than 1/4 x minus 1. I'm going to plug in zeros. Half of 0 is less than a quarter 0. So now I have 0 is less than negative 1. And that is not true, which is what we wanted. Say yay. We wanted it to not work. I know that sounds silly to write, but it's pretty. You don't want to go back to your work and think that it ended with it not working and that's what you want all the time. So be very specific that we were looking for it to not work this time because we chose a point not in the solution. So as long as you know what you're doing, you can always pick 0, 0. You just got to be aware of what your goal is with 0, 0. Do we want it to be in the solution or do we not want it to be? This time we did not want it to be, and it worked. Or it did not work, however you want to look at it. Alright, normally I would put the rules up in the beginning, but I wanted you to see how it worked first. So these are the rules, these are steps. When graphing inequalities, you get the y alone, just like graphing equalities, equations. You want a y alone and positive. It's not alone if there's a negative stuck onto it. 2, you state the slope and y-intercept, or a list of points in a table. Sometimes people do that, but you can. So that's what we did. We wrote M and B. 3, plot points on a graph to create a boundary. That's graphing the line part. Connect the points, and then this is where you have to start thinking differently. You use a solid use a solid line if you have less than or equal to, or greater than or equal to, and a dotted line when it's just less than or when it's just greater than. And then here's 5. This is what I always forget, and I believe I forgot it every single time. So let's go back and fix that. We're going to label the line with the original equation. It actually doesn't have to be original. When you label, it doesn't have to be an original or new one, because you're just labeling. And then 6, choose a point not on the boundary line. So in other words, don't pick one right on the line because that gets confusing. Pick something that's clearly on one side of the line or the other and test which way to shade. So like we said, we kind of shaded first using that really quick trick, but then we made sure that we checked that we shaded the correct side. So we did it a little different than step 6. I like my way a little bit better, the way I was doing it. So let's go back. We're going to end this by making sure I've done the right thing, which is label. So this is y is less than x plus 3. The next one was x minus 2y is less than or equal to 4. I'm just going with the originals anyways. And then the last one we did there, we'll label it with blue. 1/2 y is less than 1/4 x minus 1. Normally I'd say label the x and y value, or x and y axis too, but it's not as important, and they're usually labeled for you already on a Regents. Okay, I think that's going to do it. I'm not leaving you with any work. We'll have a couple questions in class, probably a little easier than last time, and then we'll do a little practice with this. We might do some whiteboard practice too. All right, good luck, good night, see you tomorrow.